Lesson 4. How are cold environments under threat? Klaus Topfer, Executive Director of UNEP, says, at the turn of the new millennium, less than 15% of the Arctic's land was heavily impacted by human activity and infrastructure. However, if exploration for oil, gas and minerals developments, such as hydroelectric schemes and timber extraction, continue at current rates, more than half of the Arctic will be seriously threatened in less than 50 years. Up to 80% of the Arctic will be affected by mining, oil and gas exploration, ports, roads and other developments by 2050 if industrialization of one of the world's last wilderness areas continues at current rates. Scientists with the United Nations Environment Programme, UNEP, are warning that the Arctic's rich and abundant wildlife will suffer with birds and large mammals such as reindeer, caribou, polar bears, wolves and brown bears at greatest risk. This will lead to increasing pressure on the lifestyles of indigenous peoples, as well as on precious habitats and ecosystems in the area of the world vital for wildlife and for regulating the Earth's climate. Infrastructure brings primary industrial development, but also secondary, more controlled development. In terms of increased human immigration and settlements, these in turn increase the risk of deforestation, overgrazing, social conflicts, pollution of water, land degradation and fragmentation of habitats. Our findings show that even with the stable rates of industrial growth mirroring those that have occurred in the latter part of the last century, an estimated 50% to 80% of the Arctic will reach critical levels of human-induced disturbance by 2050. Many different groups of indigenous people, including the Sami, Nenets, Komi and Chukchi of Eurasia, and Dogrib, Cree, Innu and Yupik of North America, rely on the hunting and herding of reindeer and caribou. Such peoples have, over thousands of years, developed social networks, traditions and cultural lifestyles based on the movements of these animals. But the Globio report warns that industrialization of the Arctic threatens the traditional existence of many indigenous peoples. It is difficult to travel far in the Arctic without encountering the workings and effects of the global industrial system. Vast oil-producing complexes such as Prudhoe Bay on Alaska's North Slope are linked to metropolitan centres by ever-increasing network of gravel supply roads. Oil and gas pipelines, some of them rustling and leaking, snake across hundreds of miles of tundra and mountain ranges, while seismic trails and the scars of clear-cut logging are etched deep on boreal and tundra landscapes. Even in remote areas far from any human habitation, unwelcome encounters with rubbish and industrial and military waste are reminders of the fragility, brittleness and vulnerability of the Arctic, and of the intrusive nature of human activity. In the northeast of Greenland, for example, an unpopulated area with a protected national park, plastic bags, fishing nets, barbed wire, fuel tanks and beer bottles are to be found washed up on the shores seldom visited by human beings. On Alaska's Seward Peninsula, local people have discovered corroding aircraft batteries in rivers which provide drinking water for summer fishing camps, vehicles dumped by the United States military, and canisters of mustard gas half buried in the tundra. And in 1994, 5 years after the Exxon Valdez ran aground, spilling 11 million gallons of North Slope crude oil into Prince William Sound, it was possible to talk to fishermen from southern Alaska still trying to come to terms with the impact of the disaster on their livelihoods. The Exxon Valdez incident in Alaska's Prince William Sound in 1989 illustrated the dangers of transporting oil by sea, and recent leaks from Russian oil pipelines have raised questions about their reliability and safety. Somewhere between 5 to 10% of Russian oil production is thought to be lost through leaks, oil well blowouts, waste and theft. Minor discharges from marine vessels such as tankers, freighters, fishing boats and coastal ferries operating in northern waters are also a source of pollution and may not be readily monitored, but their impact on the Arctic ecosystems may be significant nonetheless. Polar bears, seals, sea otters and seabirds are already frequent casualties of oil contamination, while bowhead whale migration routes through oil and gas lease areas in the Chukchi Sea could be seriously disrupted if development goes ahead. Scientists have described how the curiosity of polar bears leads them to readily investigate unfamiliar objects and smells, including offshore drilling sites and oil canisters in Arctic villages and Inuit hunting camps. They are also at risk of death by ingesting oil directly, through licking oil fur, or through eating contaminated seeds or birds. Oil persists for longer periods in the Arctic because low temperatures result in low rates of evaporation, and relatively little light during most of the Arctic year reduces ultraviolet radiation necessary for decomposition. The impact of oil pollution on tundra environments may remain visible for several years, with lichens, which constitute the main source of food for reindeer and other plants, especially vulnerable to contamination. On land, snow and ice cover may stabilize the oil during winter, but spring melt only releases it, thus coinciding with the arrival of migratory birds. While in marine environments, Arctic sea ice reduces wave action, which in more temperate regions will help to mitigate the effects of oil pollution. Oil fires also produce smoke clouds that are concentrated at very low atmospheric levels by Arctic air inversions. Not only do smoke clouds from oil fires reduce crucial levels of solar radiation, they contain pollutants harmful to both human health and to productivity of marine and terrestrial environments. Other threats to Arctic environment and human populations are less visible, but no less real. UVB radiation has effects on human skin, eyes, and the immune system. Atmospheric and marine pollution means organic contaminants enter the food chain at every single level. Because these persistent organic pollutants break down more slowly in the Arctic than in warmer regions, they pose greater dangers to human and animal populations. For example, polychlorinated biphenyls, oily man-made substances known more popularly as PCBs, and which evaporate from rubbish dumps and burning oil, have been found in the breast milk of Canadian Inuit women. PCBs cause cancer and damage the neurological and hormonal development of children. There is also a high concentration of PCBs in some seal, walrus, and polar bear populations, which threaten their reproduction. High levels of mercury have also been found in liver tissue of ringed and bearded seals. Both species constitute the primary source of food for polar bears, as well as forming the basis for subsistence hunting culture of many Inuit communities. In Greenland, 1 in 6 people have dangerous levels of mercury in their blood, while other toxic chemicals found among Inuit include toxaphene and chlordane. Tundra and marine ecosystems are also at risk from dumping of nuclear waste and heavy material contamination. Nuclear test explosions have been carried out near Novaya Zemlya in the Russian Arctic, while radioactivity affects the Northern Atlantic and Barents Sea. The highest levels of radioactive pollution along the Norwegian coast, for example, have not originated in Russia, however, but from radiochemical plants in the United Kingdom and France. Global warming caused by increased emissions of greenhouse gases also threatens to have a significant impact on the Arctic and on the livelihoods of indigenous peoples. Arctic ecosystems are extremely sensitive to climate change and are likely to increase in average winter temperatures of between 3 to 6 times the global average predictions. There is already evidence that winters in the Arctic and subarctic regions are becoming much warmer. While the average temperature of the Earth's surface is predicted to increase between 2 to 5 degrees Celsius during the next 50 to 100 years, the Arctic regions are expected to have greater temperature increases of up to 10 degrees centigrade. Global warming could reduce the extent of sea ice, Permafrost would thaw more quickly in spring but take longer to refreeze in the autumn. Fish stocks could fluctuate, and migration routes of animals such as caribou would be disrupted as forest tundra and coastal habitats adapt to new environmental conditions. Climatic change is also likely to disrupt millions of migratory birds as they find less food at stopover points. Wintering sites and breeding grounds, hunting, trapping, and fishing activities would be severely affected, and the economies of small, remote communities, already vulnerable to changes in global economic conditions, would suffer drastically. Arctic climate processes influence global conditions, which in turn contribute to further change in the Arctic. Some scientists, however, are careful to point out that while global temperature data sets seem to suggest that there has been a surface warming of between 0.3 and 0.6 degrees centigrade over the last 100 years, regional studies do not confirm that there are any worldwide trends. Rather, atmospheric temperature trends in the Arctic are seasonal and spatially variable. Nonetheless, there is some considerable alarm at the prospect of global warming. While affecting the Arctic, melting the polar ice caps and resulting in a rise in sea levels, thus threatening coastal towns and cities and low-lying countries such as Bangladesh and the Netherlands. The melting of Arctic permafrost will release huge amounts of methane, which will contribute further to the greenhouse effect. Climatic warming may also result in greater cloud cover and higher levels of precipitation as a result of more water vapour, another greenhouse gas, in the atmosphere. A hole in the ozone layer has been found over the Arctic as well as over the Antarctic, and if the ozone layer thins or if the hole gets bigger, then scientists argue that there are a number of implications not only for the Arctic but for the planet as a whole. As ozone, a gas found between 20 to 50 kilometers up in the Earth's atmosphere, helps to reduce or filter high energy ultraviolet radiation from the sun, the thinning of the ozone layer means that the more ultraviolet radiation will reach the Earth's surface. Possible consequences include mutation in vegetation growth and an increased risk of skin cancer in human beings and animals. Ozone depletion may also contribute to the gradual warming of the Earth's surface. One of the main causes of ozone depletion is the emission of chlorofluorocarbons, CFCs, human-made gases used in refrigerators and aerosols, which are unreactive and once released into the atmosphere help to thin the ozone layer. The Arctic has the unenviable advantage of being a natural scientific laboratory for studying global environmental issues. Some of the most alarming illustrations in recent years that the Arctic environmental problems are global rather than regional concerns include the contamination of lichens and reindeer, which eat lichen, in northern Scandinavia in the aftermath of the Chernobyl disaster. The discovery of PCBs in breast milk of Canadian Inuit women, which were found to be 4 times higher than those found in women living in southern Canada, and Arctic haze, which provides the best example of long-range transportation of atmospheric pollution. A photochemical smog, which is most problematic during winter, Arctic haze contains pollutants which originate from industrial activity such as coal and oil combustion and steel manufacturing, which are transported by air from Eurasia towards the North Polar region, where, because the colder air is more stable, the haze particles can persist. Sulfur particles are the most common component of Arctic haze, and not only do they threaten low-level ozone, they disrupt atmospheric energy flows and contribute to acid rain. Other pollutants, including copper, lead, zinc, and arsenic, they have been found in lichens and mosses in Alaska, Sweden, Norway, and Finland, but also fall in some of the Arctic's prime fishing grounds.